And we're back. Cool. OBS is still doing its thing. Why is it doing that? Let's give it a second. Right. So, ooh, this is posted. Welcome to another episode of Reasonable Coding. Today we're going to be talking about property-based testing with the library called qcheck or qcheck, and also a library called alcotest for doing testing, unit testing more specifically. And okay, so here's a description in case you haven't read it. We've built a lot of tools and programs in the past 13 streams, but never once have we run tests for them. And that mostly speaks to me prototyping, and not about the current state of the ecosystem for doing tests, which is highly sophisticated, which we'll see in a second. So I figured that we should do a stream where we take care of this. We take a look at how we can test things. We take a look at essentially what tools are out there for verifying that our programs are correct. Because however powerful the type system can be, keeping our logic in check is a good idea. Essentially, you may actually have a type system encoding something that very safely will do something that makes no sense for your program to do because the program is wrong, right? So duplicating this intent, what the program should be doing in tests, usually help us make sure that we are doing the right thing, and not only that we're doing it right. And for this, we will explore two tools. The first one is called alcotest, and then we'll take a look at qcheck. And the first one is essentially a tool that will let us write and run our unit tests, pretty much like we would do in other languages, like with JUnit in Java, or Jest in JavaScript, or eUnit, or any of the XUnit tools. And the second one is it's a much more powerful tool that will let us express that a program should follow certain should present certain properties. And based on those properties, right, it will generate random inputs and make sure that the program complies to those properties or that it doesn't. If you work with PHP before, they have something called, I think it's test generators that generate, really big amounts of data for test purposes. It's along the same lines. It tends to be a little more formal to do property-based testing. But let's start by the beginning. What the hell is property-based testing? It's something that I won't be able to dive into too much today. Of course, it will become more obvious as we go through the library and making some examples. Most of the examples that I have in mind that I'm thinking of right now, this is not a prepared stream. It's just me exploring the library. Are Most of the examples I think will be fairly straightforward. Ultimately, I would like to be able to do something like generate GraphQL data for testing purposes. But yeah, what I wanted to mention was that there's this amazing book by Fred Hebert of airline fame called Proper Testing. Proper is a library in the airline world, and this is the free version of the book. This is where I took the drawing from. I think it was very cute, and it kind of resembles sort of what we're going to be doing. You can even see the little plugs here have the surprise faces, like, no, what are you going to do with that? And it essentially presents the foundations of property-based testing, and it presents some tools on what the hell is a property and how to do different sorts of properties. I don't think we'll be able to cover everything that's covered here in this book, which is fairly thorough, but we'll get somewhere. Now, the interesting bit is that the book took off, and you actually can buy the pro version of it by the pragmatic programmers. And not that I endorse the books they have in general, I don't. But this one in particular, because I've read and I've seen a lot of what Fred Hebert has done in the past, I have a lot of faith in. And I'm actually waiting for it to be available in dead tree format, in good old paper, to get me a copy. And that should be sometime in January. So if your birthday is in January, then you know what to get. Otherwise, if you like, you can lie to yourself that it's a late Christmas present. That could also work. Just get yourself a copy. And I have no affiliation with anything whatsoever. I just think it's a good book to have in your shelf. All right, so let's begin by the beginning. We want to take a look into a library called alcotest. Library, okay. And I'm going to try to do all the searching and finding myself so that you can also see a little of what it looks like to look for things in the OCaml and Reason ecosystem. And we have the first hit here. Normally, I would search for OCaml. Reason has a lot of JavaScript things that are normally in the way of working with Reason Native, but every now and then you get good hits. So I'll open this thing. I'm going to drink some more. I wanted to show off my new mug. I got a mug for Christmas, an Arrowman one, which is pretty cool. Okay, 1 second. Realized I forgot to open the dashboard in the application in my phone. But now it's open. Cool. So now I can read you. I have not yet finished Twitchport, which is a project I started two streams ago, to have a complete dashboard for Twitch on my terminal that I can have open at all times, so I can see who's in, who's not, and so on, and answer back possibly without having to pick up my phone. Okay, so alcotest, I'll make this a little bigger, is a lightweight and colorful test framework. Nice. Exposes a simple interface to perform unit tests, and it exposes a simple testable module type, check function to assert test predicates, and a run function to perform a list of unit-to-unit test callbacks. Okay, that sounds very straightforward. alcotest provides a quiet and colorful output where only faulty runs are fully displayed, and at the end of the run, with the logs already ready to inspect, with a simple yet expressive query language to select the test run. All right. So we have a sample test here. It's a module. It has two functions that we're going to be testing, and then tests. And you can see here these are functions that take a unit to evaluate. And this is checking the char. Okay, I'm not entirely sure how to read this. This is a function invocation, right? And so is this. So this is sort of saying check character, and here I assume this is a function that they provide to check for character equality. And then this is the name of the test. and then we have A, and then the other thing. So we're comparing these two things here using this function, and this will be the name of the check, I guess. And then we have a test set, which seems to be a list of triplets, where the first name is the name of the test, I guess, again, or maybe the function that we're testing. Then a marker of whether it's quick or slow, and then the actual test that we want to execute. And then when we want to run it, I guess this will be the test suite or the test run, and then each one of these will be test suites. I'm using a little bit of the terminology that we have in, let's say, jest. Okay. This makes some sense so far. Anyone else confused? Is it just me? No? Alright. Okay, so the result is a self-contained binary that displays the test results. You can use simple and then execute it to see the runtime options. Alright. And then we can filter the tests to run by supplying either the exact test name or the exact test name and the test case number. Okay, so if you want to run this test case, we put the name, and then if you want to run the first one, we put 0 for capitalize. Sounds about right. Then there's distinctions between quick and slow tests, passing custom options. All right, and then asynchronous. Yeah, the ad hoc test suite actually runs very nicely. And we can integrate this one with qcheck for later on. All right, so let's say we want to use this library. Let's say we want to do a small test. We will build a very small module that does some simple arithmetic, and then we will try to write some unit tests for it. Or actually, if you're into it, we can try to do some test-driven development. Ooh, I hear the audience saying something. Cool. Let's see how the hell we can use this. This is building an executable that we will run. So I was expecting us to have to run a different executable that will run our tests. That kind of makes sense that it has to compile the tests to be able to run them. So let's take a look at examples. All right. There's something called simple here. Some disclaimers. Okay, so this is exactly the example that we have in the README, or very similar at least. And then we have a Dune file. Interesting. So the executables rule will build an executable file out of modules that have some of these names. Go back, we should have a bad.ml and a simple.ml here. And then we just put the library alcotest. So this sounds like a fairly straightforward way of getting the library to test with Dune. You just need to build a testing target. Oops. So let's need a repo here, and let's call this resonative testing. Sorry, resonative testing. We're going there, and we'll just do a touch, Dune project. And we need to tell it to use the lang for Dune 1.5, and the name will be Reason Native Testing, and then using formatter 1.0. And this I think I know by heart. Let's double check. Yeah, this I already know by heart, but You don't need to remember them. You can just copy off different projects. As long as you change the name, everything should be pretty much okay. And I'm also going to copy from the Cactus project, actually from the, where is it, Switchboard project. I'm going to copy the git attributes file and the git ignore. Cool. So now Git knows what to ignore and what to not to ignore. And then when we push this code, GitHub will know that it's reason and not C++. For some reason, on there. For some reason, it tends to believe that some reason files are actually C++. I do not know. All right, so we want to mark a folder called test, and we want to build a folder that has some source. So let's just do source, and then we do a mod, or let's just call it math. This will be a module, right? And then in here, we want to have a function that adds two numbers, x and y, and returns x plus y. And let's do a function that multiplies two numbers, x plus y, x by y. Sounds easy enough. We got the two functions there, right? I'm going to write the small Dune file in the source, so we can say there'll be a library, which name is going to be math, right? And it has no dependencies, so we can do that. And now in the test folder, we want to write our math test. And here, the name of the file has nothing to do with anything else, right? It's just a file name that I'm using. We could use something different. And we're going to write a small Dune file inside the test Dune. And this thing will actually have executables. And the executable for this thing will have the same name, test, math test. But we will need to use the alcotest library. And we will need to depend on the math library, which is the library we're testing, right? So if I do build everything, it should say, okay, we don't actually have the library alcotest. Camel install alcotest. Let's see if we have it installed at all. We didn't, so we will install it now. Cool. All right, now we have it. Let's build the whole thing. It says there is no library called math. Interesting. And I think in this library should be a public library. So we will use a public name that we could write as math. And when we do this and we build, brilliant. It's telling us that we need to write a PAM package file. And that works. So we'll just save a file as math.pam and then build again. And we have built everything. So this should mean that if we go into build default, we should have a test folder and we have a math test executable. That if we run it, it should have, well, nothing right now because it's empty. We have these two functions and we want to write some tests for them. We want to write some silly ones like, you know, -1 added to -1 is 3. So let's do that. Let's say that we will have our add 3 -1 -1 equals 3. And let's take a look at how we actually wrote the tests, right? And here we need to open alcotest every time. So I think I am going to open it over there. And it looks like we don't necessarily need to okay, yeah. And as it turns out, tests are functions, so we can write a function there, right? And then we need to do something in here. And we seem to have a function called check, that if we look at this, it will check how to test something. it will have a string, which I guess is the error name, and then it will take two values and we'll compare that they are the same. So we know that we want to check for integers, so we can do check and then give it a testable for integer, which is right here, is int. We can say check int, and then -1 plus -1 equals 3. So then we can use our function and we can say math add -1 -1, and this should be equal to 3. Cool. So we have one test now. Let's run it and see it fail. How do we run the tests? We need to create a test suite, which is a list of things. And this list is a list of tuples that have, I think, the name of the test first. We can say math add, and the second thing here would be whether it's quick or slow. Let's say quick, and the last thing will be the function that we need to run. There. So now that we have our test suite, right? We can run it. And we do this by just saying alcotest run my module tests, and then we give it the test sets, the test suites. So suite 1, cool. So we build everything again, and I'm actually gonna open this new window below where we're gonna be constantly building everything. We can run the tests, and we'll see that it fails, which is great, because -1 plus -1 should be -2, but instead we got a 3. That kind of makes sense. Okay. By the way, is the volume all right? Hey Ulrich, how's it going? We're gonna be doing testing. First with alcotest for writing some unit tests, and then we're gonna explore property-based testing with qcheck, really. Yeah. So we have a test that fails, and that's fine. The test is clearly wrong. It should not be this. So we need to change this to be -2. If we save it, it rebuilds, and we can run it again, and then it says everything is good. And it shows that all the test results are actually available in this place. Great. We can also add another test for our multiplication. So multiply 0 by 10 equals 0. This should be -2. Change the name of this thing. And then here we can just say, right? Now we can multiply this thing, 0 and 10, and it should be 0. And of course, because we have some test suites here, we need to add another element, mul, and let's say mul 0. Here you go, saving it. Wait, something went wrong. Oh yeah, we forgot a comma. There you go. Cool. And we build, and we run it, and it works. And we can also tell it to run suite 1. Oops, no wait, that's not the way I expected it to work. What is it? Yeah, it should be suite 1, right? Suite 1. Oh, test suite 1, and then 0, 1. No, this is not doing what I expected to do. Let's take a look at help. This exec table that we get here, right? It has a few things that we can use. Oh, nice! It automatically can get us the results in JSON. It can run only the quick tests. Which, by the way, this is not necessarily why qcheck is called quick. Okay, so what happens if we do a list? We get the tests, and then we also have a test command that runs everything. What happens in here? Okay. I'm gonna try to match something. If I put the full name, it runs there. But then I don't want to run all the tests. 0. Oh yeah, okay. When I call this with 0, right, it shows me all of the tests on the suite, but it tells me that this one has been skipped. Okay. This is interesting. This was a very fast setup. We have something. Sorry, long day. And we already have something that we can run to test things. So what happens if we pass JSON in here? Okay, we get the successes and failures and time. This is really fast, but of course, it's doing pretty much close to nothing. Now I want to see if we can parse that JSON result with JQ. No, we can't. When we do client, Q is for the quick tests. Huh. So I wonder if there is a flag so that the only thing we see is the JSON result. You can tell by this flag over here, the help format one. This has been built with command liner. Okay, verbose. So if we do verbose quiet, oh, this is flag. Let's see the help for test. Interesting. I would have expected this to essentially have only output of the JSON flag. I wonder if the JSON output is coming from different. No, it's coming from the exact same type. Huh. Okay. I guess you can always do head 2. No, sorry. Tail -2. And then we have something that we can there you go. We can parse with a tool. It's fairly straightforward to do something that on CI, right, runs your test and then extracts the output, parses it with something like JQ, and counts the amounts of failures, right? And then if this thing is equals to 0, then we know what to do, else we fail. But this looks quite uninteresting. I mean, sure, we can write some tests here, we can evaluate them all. I wonder what would happen if we just multiplicate this one, like take the list and run this list hundreds of times. I'm going to do a silly thing. I'm just going to press P a lot of times here. And And that's still not that many tests. If we build and test the whole thing, it's fairly fast. It's a little verbose. I guess with E we can only see the errors. No, we see everything all the time. Okay, so let's go back. This is not helping us right now. All right. I would say let's go see how another project that uses alcotest runs its tests, and it has a lot more tests than we have right now. So we can get an idea of how this scales up, this pattern, because right now it's fairly straightforward, but we also have just 2 functions to test and only 2 tests, right? And one such project that I know of is ODOC. So let me just go to the master branch. And if we build this thing, did I have to pin .xml to development? I forget. Hopefully won't. Hopefully this will be okay. This will be okay. Cool. Installed. If I want to make tests here, this will build something, which is test executables, among other things. And oh yeah, doesn't run at all. Huh. Yeah, I think this is a failing. Let's see what makefile does for testing purposes. Okay, so this will essentially build test parser run test without a buffer and essentially one job. But this is failing terribly. I wonder if it's to do with... Okay, I'm stashing a bunch of things here. See you. Oh, right. I'm in a very broken branch. This is not where I should be. I should be reset remotes. Right, the upstream is the one I want to fetch. And then I can do hard upstream master. Sorry. Messed it up. Cool. That looks like a more familiar commit. So let's clean the whole thing. And then let's build again. And you can see there's more stuff to build now than there was before. And then after that we'll run, I'll make test. And this should be building these 2 targets. I'm curious what this run test thing is. So I'm going to go into the HTML tests. Test, HTML, and there should be the run test there. No, there isn't. A Dune. Okay. Install, markup. And here we're defining an executable, we give it some libraries, and we say that it should be opening by default this module. Okay, that sounds pretty familiar, pretty much like what we have. But we have an alias here that will actually run the executable. And this is running about, yeah, there's no new test to be run, but it runs tests in about, well, depends the sort of test, right? Here is like 300 milliseconds for 33 ones, but these ones are actually rendering down HTML. And up here we have tests for looking at the actual internal syntax of the library, and these are much faster. So we run about 800 tests, 888 in the same time, 226, 345. Okay. So this seems to be the way to use this library. You just write your tests. If we go into a file that defines some of these tests, we'll see what I'm talking about. Test HTML, and we have a test ML, right? Which is the one that's referred to here. And command label, we have some environment cases. So these cases are going to be built automatically for us. And yeah, this is not going to be too helpful. Essentially, we're generating a lot of test cases based on source files and their outcomes. So if we were to do something like that, we would say, given a range of numbers, right, we want to test that our math.add function actually works just as well as the normal, the pervasive addition, which is the one that comes with some library, this one, right? You see below there, int. But if you're going to be generating inputs that are not based on a particular, like a defined set of, sorry, if we're going to be generating tests that are not defined by a very defined set of inputs, such as in here you have the source files, right? We're not generating the source files, we're not generating the expected outcomes. We have those, we just need to generate the boilerplate to run the tests. You'll see here, alcotest run, and then we have support files, list mapping over the source files to generate test cases with ML syntax, and the same one for the source files for reason syntax. Right. It really looks like alcotest is it's fairly straightforward. If you set it up in 20 minutes, you get it up and running, and then the rest thing you need to do is just write your tests. No more excuses. Now you can use alcotest for this. Should be quite alright. Cool. Let's take this one a step further. Let's see some of the features that alcotest has that we maybe want to use in the future. I know that there is some asynchronous tests that we can run. So I'd like to run one of those, and then we can take a look at running property-based tests. One sec, I need to blow my nose. All right. So it seems that alcotest provides a module that can be used to wrap LWT test cases. And if you missed some of the last streams, this might be a little unfamiliar, but LWT is just a promise, a futures library, and a concurrency library for return native and OCaml. The basic idea is that instead of providing a test function in the form unit to unit, you provide one with the type, okay? And an alcotest LWT calls main run for you. Okay, so that sounds like we can just switch up our tests a little bit, and they should work just fine. However, there are a couple of extra features. If an async exception occurs, it will cancel your test case for you and fail it rather than exiting the process. That's nice. You get a given switch, which will be turned off when the test case finishes. You can use that to free up any resources. Okay. I am not familiar with LWT switches. I wonder if we actually need them. But as it looks like, we can essentially change some of our tests to do something else than what it's doing right now. So this one is using fail with to throw an exception, but I wonder if we can just wrap this thing in LWT, right? LWT async. So now it's running concurrently somewhere else, and then we just return. Oh no, wait, we actually need to return something that will be cleared up by the time that this is run. So because this is not asynchronous, right, this is just multiplied something very, quite a synchronous way, we can just fake that there will be some asynchronicity by saying LWT dot wait, and this will give us two bits and pieces. The first one is the waiter, and then the awaker. We can use the waiter to keep someone else waiting for us, and we can use the awaker to essentially awake whoever is waiting on us. And then after that, we spin up this little computation. And after we do this, because we need to return something, and I think the type of this thing is unit, yeah, we can return Unix dot, what is sleep? Yeah, sleep 1 second. So now this test that we have over here, right? Our tests do not know what the hell's going on because we need the LWT module and LWT.unix. Great. So now line 10 says this needs a float. We're going to do 1.0. I expect a few other things to fail, like in line 17, this is a list of tuples, right? So the tuple clearly has to be homogeneous, which means we can't mix synchronous and asynchronous tests. We will have to make all tests asynchronous. We can do that fairly quickly. I'm just going to duplicate this thing, actually just the body, and then replace that in there. And then we're going to say this would be 0.2 per time. Cool. Now we should have 1 and 2 tests that are completely asynchronous. And now line 26 will complain because the test suite is not what it expects, right? It's expecting a list of tuples that have a test name as a string, the speed level, and then functions that go from unit to unit. So this is where I think we should call alcotest LWT. But we don't have that installed. So let's proceed to installing it, alcotest LWT. It's a different library. And after we do that, then we should have it available here, and we do. Great. And then in here you should have, it has something called test case. Let's see how they're using it beforehand. Brilliant. Okay, so we just need to call each one of our test cases with this function, and then they'll all become synchronous test cases that we can use. So in our test suite, right, which is this bit, we have these tests. So what we can do is we can do list.map, and we can map with alcotest test case. And now this should be a slightly different. These are test cases now. But this might actually not work. Okay, no. You know what? Instead of mapping, I'm going to write the name of the function there. T dot test case. Line 22 says that it has a problem. And that is because our tests now have a different signature. The signature is a switch that we'll ignore, and then essentially an empty tuple. The empty tuple. Cool. And now, of course, we need to make use of our awaker, so we can, after we sleep, the moment we're done sleeping, we can just say wake up later, awaker, and then we give it nothing. We can reuse the same logic here. This is just us faking a delay in our test, right? If our code actually was asynchronous, then it would not need this. And we can open the infix module to get access to the operators. Great, line 8. And wake up later does not, it returns a unit. Okay. So that means we can just map. And this worked. It's a success. So now we can run the same thing that we were running before. We'll try to run it through Dune. And then this was test. And then main. Okay. Okay. Run test is not something that's defined automatically. It's an alias that we can define. And it's a pretty handy one at that, so we'll copy it over. It takes a name, it takes an action, something that it will do, and it takes some dependencies that it needs. So it looks like we only need test, the executable, right, in our case as well. And we want to run the same thing. So let's do that. Name, run test, and then action will be run, and then in here we need to give it the name of the executable, and we can use this syntax to essentially let Dune figure out what the full path to this thing will be. So we'll do x and then test dot, actually in our case will be math test.x, I believe. And then the dependencies that we need is math.test.x. And cool, Dune said it was cool. I'm gonna add some syntax here. Actually, I might be able to track it and get. Ooh, look at that, fancy. So now we run the same target. It will build, and then it will run our tests. And it's a fairly fast running, right? So now if we run it again, I don't know if it's, yeah, there's nothing to be done, so it will not essentially it will not do anything now. Now, if we change our code, let's say we add 1 here, right? Then running this thing will recompile and it will run the tests that we need. And of course it failed because the tests are saving our asses. So we can do this again, and it runs and everything's good. And because this is asynchronous, we should be able to run many tests that have to work with the file system, for example, with I/O, or network requests in a much faster way. For a particular case that we had before, this is a little overkill. But it still does the job. Okay, so I'm going to save this one as math test async RE, and then I'm going to roll back a little until we get the regular tests that we had before. No, damn it. Okay, this is what I wanted to take, and then I'll go all the way forward. Cool. And I'll open math test, and I'll just put in the old stuff in there. And now in Dune, we can just say there will be math test and math test async. The async version requires a little more things than the other one. And now, because we have multiple modules, we want to say modules math test and math test async. I wonder if I have a typo. Oh, I know what happened. I wrote that file in a different place. Let's move it back into the test folder. Cool. So if we add to this thing that we want to run more than one thing, I don't know if there are more than one actions. We might be able to just have one target that runs all the tests. We can definitely make sure that we have. Let's see if that works. Nope. Okay, so I guess the one is for each one of them. Too many arguments. I wonder if there's an actions. Nope, there isn't. I wonder if I can have more than one action. Nope, we can't. So essentially we will need to have a separate alias for this other thing, which makes me think the reasonable thing to do is to include all of the tests together. But we'll have to split this into our synchronous and asynchronous tests somehow, or integrate them back. And I'm not entirely sure that that's worth the rest of the string. Maybe we can take a look at that. Maybe we don't. What do you think? You want to go straight into property-based testing? No, yes, maybe. I'll get some water in the meantime. Cool. So I'll actually run tests sync, and just do 2 aliases for them. Perfect. We can run make test now, and just run all tests. If there's anything to run, that is. If I change one of this, brilliant. Okay, so let's go into the property testing side of things. I'll assume that you know how to test your stuff, which is good. We've been through this. Oh, by the way, this is what running tests with ODoc looks like, in case we didn't see that yet. Or have we? And it seems to be okay. It seems to be the only framework using colors, which is great. All right, let's. I'm good here. Let's go to the other one. Now, qcheck is a library that's inspired by the qcheck library, and the qcheck library is for Haskell. And I don't know if the docs are nice on this one. It's a library for random testing of program properties. The programmer provides a specification of the program in the form of properties with functions, which functions should satisfy, and qcheck then tests that the properties hold in a large number of randomly generated cases. In this case, specifications are expressed in Haskell using combinators provided by qcheck. qcheck provides combinators that define properties, observe the distribution of test data, and define test data generators. Alright, cool. It's the official manual. This is a very detailed tutorial, apparently. You can take a look at that. Methodology, generating stuff. Okay, if we're going to be looking at a tutorial, we must as well look at one that works specifically for a camel. But I leave this here because this looks interesting. It looks dense, so I'll read it. And okay, this is the camel version. It's inspired by the original one. It has combinators that we can use to essentially generate values, right? Okay. Let's begin by the beginning. Let's install qcheck. Install qcheck. Yes. And I like that by default it comes with a unit for a camel unit. An introduction to the library. Let's see a few tests. Let's open the top level and type the following to load qcheck. Okay. This is Utah. Yes. Qcheck. Oh, this is very interesting. If we call do new top, then we can pass it a folder and it will automatically have things work. All right. What we want to do is we want to load. What's it load or require? Require. And we can do this here. Okay. So I'll close. I use a regular utop. Use a require qcheck. Now we seem to have qcheck installed. Loaded up in the repo. Great. So we're going to be following the tutorial to get an idea of what we can do and how to do it with the library. And then after that, we'll try to write some properties for our program. And hopefully this will be enough to get you started writing more tests in whatever it is that you're doing and writing better tests by using different methodologies. Not just unit testing, which for the record, if we only have these tests, right, then -2 and 0, then these are perfectly valid implementations of our program. In fact, if we test this thing, oh, sorry, wrong input, it was -2. Oh wait, was it? Okay. -2, my bad. If we write this, right, then the test that we have written will say that everything is okay. And I guess that would explain better the motivation behind property-based testing, right? The point is, sometimes when you're writing some code, you have an idea of what you want to test because it's very specific. Like, I don't know, let's say you're working in a bakery and you're keeping track of some sort of baked good, right? And you have a status for it. So if you add a type for baked good, then it has the status as a type in there. And then you want to make sure that it only goes from into the oven if it's unbaked and out of the oven only if it's baked, right? That's really straightforward to do. In fact, the camel type system can do it for you. So if you have the status, and let's say there will be something called status, and this will be unbaked, and then this will be baked, right? Then you can say make to make a new one, and this will take nothing and return you a baked good that's unbaked, right? And you can just say yum, or like a cupcake. That will be a cupcake. So if I call make here, right below, then the type of this thing is, oops, if I save, where do I have a typo? Type status, baked, unbaked, line 6. All right. This should be a function. There you go. It's still with errors? What the hell? Cupcake. Line 6, character 17. Make unit. My bad. Now we have another error, but somewhere else. Line 40, 6, character 40. Okay, now this one I don't get. There you go. That was it. So this is a baked good that's unbaked, as you can see below, right? And if we have a function called bake, this should take a baked good that essentially is unbaked, and then return you a baked good that is baked, right? And we'll ignore it right now. We're just gonna return new cupcake, and where's the typo here? Right, there you go. So now we go from unbaked, and we pipe this into bake, and then we get baked good, right? So the type system can help you with this thing. You would need tests to test that your function that heats up the oven, for example, for one thing, goes to works fine if you go to 200 degrees, and that will not require a lot of test cases. But here, if you were to test that the add function works very well for a lot of cases, then you will need a fair amount of them. Why? If we had another one, I'm just gonna call it add2, right? And if we have 0 plus 2 equals 2, then here we have another test case, and that we can run, and it will fail because sorry, we didn't add it. Yeah, that's it. And this will fail because our test essentially return our code returns -2 all the time, right? But we can absolutely have a look at this thing, right? And for example, this would be x. Just say if x equals 0, then return 2, else -2. And that's a very weird add function, but it passes all of our tests. You know what I mean? So when the amount of test cases that you have to write is too big, that means might be a symptom that the input or the domain of the problem that you're trying to model is too big. And that's precisely where a tool like qcheck and property-based testing as a general tool will help you. So in the example that we had before of the cupcakes, if there was a lot of variables involved in cooking or baking or over baking the cupcakes, then it would be a very good idea to test all of the ranges of those variables, like oven heat, right? And then you want heat, you want this thing from 0 Celsius all the way to like 200 Celsius. And then you want to make sure that if the oven heat is over 60 and under 140, no idea how much you need to bake a cupcake. Only if these things are there and the cooking time or baking time is over 15 but under 20 minutes, then the cupcake then it's baked, right? So you have a lot of combinations here for ranges of heat and ranges of time, and then because you're multiplying those, then you have an incredible amount of test cases that you'll have to manually write. So you specify those for qcheck to write for you, and then you just let it run. Well, so we're gonna fix our math function, both of them, by writing some property tests. And now I think this string more or less has a direction. Cool. We have installed the library, and now we're gonna play around with it a little bit in the terminal, and then after that we're gonna have a look at how to include it inside of our alcotest test suites. So list reverse is involutive. No, I actually don't know what it means when it says involutive. An involution or an involutionary function is a function that is its own inverse. So the reverse of the list equals to the list. Again, if you were to do unit test this, you would probably get it wrong. That's not a personal attack. It's just that unit testing as a tool for testing this sort of problems is just limited. It doesn't actually help you. All right, so now let's take a look at what this does. This is defining a variable called test, and we'll be using the OCaml syntax since that's the one that I have available right now in the repo. And we'll say run this test 1,000 times. This is the name. And generate for me a list of small natural numbers. And for each one of those small natural lists of natural numbers, this function should be true. So essentially, what we saw before, instead of writing all the cases manually, we just tell it, give me this many, this count, right, of this kind, this time, lists of natural numbers. Let's see what that looks like. So I'm going to make this a little bigger. And here we'll say qcheck. And then, what was it? Test.make. Is it uppercase make? No, lowercase. Right? And then we'll have to give it a count. And the count here will be like 1,000. And then we'll have to your name. So list reverse is involutive, right? Then we're gonna give it a combinator that will represent the type of elements we want to generate. It's worth noting that small nat seems to be integers between 0 and 100. Great. And for such thing, we will call qcheck, and then that's only on the qcheck mode. So qcheck, and here we have the list, and we also have small nat. Cool. And then the next thing, if we call this, we'll see that we're just missing a function that goes from integer list to bool, and this integer list comes specifically from the list.nat. If we were to use list chart here, then we will have a function that works with list of charts. Naturally, this is irrelevant. We don't really care what the type that we have in there, so we can use the chart just fine. And then we'll get a function that takes some list here, L, and we want to check that the reverse, right, of the reverse of the list is equal to the list. And in OCaml, you just choose one equals to express equality. So if we call this thing now, we have a test. We haven't evaluated it, it's just building it. You'll see that what it does here now, it tries to check, right, this test. So we can just pipe this thing into qcheck test, and then we have a check result. So check exception, we throw an exception, if it fails, result will just return a result with OK or error. And I like results better. So I want to run this thing. What did we miss? Let's see the signature. Check. Let's see the signature X1. Okay, so this one seems to be my bad. It did not do what I expected it to do. It did something else. We'll figure out what later. But right now, this will run for a little bit, and then it will say whether you pass or not in some way. Cool. And we can check that it runs for a little bit, because if we make the output bigger, right, then this will actually take longer to run. If you take a look there, this is 2 orders of magnitude more test cases. And you might be wondering, oh, well, why would I want a test to run this long? And the reality is that you don't need to do that many counts in practice every time. But when you're exploring a piece of code, when you're building something, it's very, very useful to have high counts to explore more random elements to find edge cases. Like after, if you run this normally at this space, like with 100,000, then maybe you'll find some things that you don't find if that you didn't find the few times that you run it with 1,000 elements. But of course, when you're running your CI tests, you don't want to spend a really long time trying to come up with something that will make the master branch fail right before you deploy something and go out on vacation, right? Which, by the way, if you're gonna go on vacation, don't just deploy something. Anyway, so this is a little bit how it works. We make a test case. We say how often do we want it to run. We give it a name. We specify what piece of data should be generated. In this case, that is 2 characters. And then we specify the property. Now, I don't know if any of you feel confident enough to propose how to test one of this, one of our functions. They're both wrong, right? Here. Like multiply returns 0 all the time, and this one returns 2 or -2, depending if the first one is 0. But we clearly need to fix them. So let's begin by changing. Let's make a new module. Test math prop tests. And in here, because we're going to be using qcheck, we can open qcheck. And because we're going to be using alcotest, we can do an open alcotest. And we had roughly an idea of how to do the test suites and run things. So we'll copy those things over, and then we'll fill them in. I'll just leave one of these as a comment so we remember. Math tests. Suite 1. Cool. So let's write the first property. Adds 2 numbers. Somewhere on here, and I'm gonna be cheating. I already saw that it does have integration with alcotest, so we can take a look at how it looks like. Cool. And there's a little sublibrary we can install that aids in the creation of these things. Great. So if you install it, I can install qcheck alcotest. Awesome, that was fast. Now we just need to include it in our executable. So I'll just make an executable here. Math prop test modules math prop test. And this needs qcheck, but also needs qcheck alcotest. Great. Now in here we can essentially do qcheck dot test, and we're gonna make a test, and let's do a count of, I don't know, 100, and then give it a name. And here we can be more verbose and say adding 2 numbers should return the I don't know quite how to express this particular property, that adding 2 numbers should return the 2 numbers added without it referring to itself, sort of. We could say, I mean, that particular property, I don't know how to say. So maybe we'll do a quick Google and say addition properties. Okay, so there's a few that we know about, but we don't care about those. We care about the property that says that addition will give you neither of them, successor, no, addition tables, decimal system. I guess that we could try defining the addition function by proving other properties such as commutativity, associativity, and identity. So essentially, if a plus b has to equal b plus a, and then associativity means that a plus b plus c has to be the same as a plus b plus c, and identity means that there's a number, there's an element, right, zero element, that when you add it on the left or right of any other number, it equals a number. So that's three properties that we can write. As you can tell, it's a completely different approach. Before we were trying to come up with numbers that we would add together and check that the result is the same. And here we're saying, okay, this function, right, has this way of behaving such that doesn't matter the order of the parameters, the result should be the same. And then it doesn't matter how you call the parameters. It doesn't matter if you nest calls of it, it should be the same. And there's one particular number that should never modify the other numbers. So we can do that. We can say add is commutative, right? Addition is commutative. Let's begin with that one. That means that a plus b equals b plus a. And then after this, we need to give it a combinator, and the combinator for this thing could be qcheck. We'll see what we have here. I would say that we can have pairs. Yeah, we have pair. So we can say pair of int, and then we'll give it a function, right? Which will get a pair of ints, so a and b. And here we will call our function and we'll say math add a b should be equals to math add b a. And there's no way for us to cheat here, right? Oh, it's doing this ugly thing. I don't know why the formatter does this. I'm gonna make this full screen so you can see it. Why would it break the function like that there? So instead of inlining it, I'm just gonna put a prop or f. So that it doesn't look horrible. Sorry. There you go. This looks much nicer. Much more nicer. Much nicer. Yes. Cool. Okay. So addition is commutative. That means for any a and b, right? If you look at the function, it will know that it's a pair of ints. And a plus b equals b plus a. There you go. Cool. And just writing this one property will take us a long way. And the reason for it is that it will be very hard to, because the numbers are randomly generated, to hardcode any correct values. And if we go back to the way that we were using this library with, here, we'll see that when we define our test suite, there is a function called alcotest that we can use. So we can just use that one. So we have a test suite, and we can just map this list with qcheck, alcotest, and then to alcotest. So here we can just add our test suite like we did before. But interesting, we don't need to define this anymore. We just need to add our test here. All right, interesting. So now that we have our test suite, then we just give our suite to alcotest.run. And we do give it a name. But this is failing. This says line 9 pair takes 2 arbitrary and int is an arbitrary int. Oh. Right. A pair is takes two elements, so you need to tell it that it will be 2 ints. So now in line 15, we get this testy. I'm gonna close the quick check. It's not being useful. When we get a quick check test, right? And there appears to be a problem, and is that this should just be quick check test. So we can remove the unit here, and now this becomes a value. It's an expression, right? The whole braced bit. Cool. So now line 8 says that we have a different problem. What? Why do we go back here? This expression has type int testable, but an expression was expected. Oh, all right, my bad. What happened was that because we opened alcotest around the very beginning, then it imported alcotest.int into our scope. We actually don't need alcotest there, but we will need to use qcheck for accessing ints there. Cool, so now we have it. I'm gonna close the repo and we can run our tests again after we do the small alias. We will say run props, and this will be math, prop test, and the dependency will be in prop test. There you go. So now we can add this to the makefile. And I'll add it at the beginning, or actually at the end, so we see the failures. And we make sure that we don't break the other tests as well. There you go. So make test. It actually proved to be commutative. Interesting. Our function is actually commutative. I reckon it would be for many inputs, right? 0 and 0, for example. So let's do something else, and let's run this 10,000 times, and we'll see if we find any failures. It's still good. I'm so disappointed. I was expecting this thing to fail much faster. We take a B and an A, and we call math add, and then we say this should be equals to math add BA. Okay, so this is not behaving as I expected. unless we get the same pair of ints every time, which will be very annoying. So we can try with a different one. We can try with small nat. And that worked. If we run it a few times, we'll see that some of the errors should be different. But essentially, we have an error. Addition is commutative, and instead of throwing at us the biggest numbers or the first thing that failed, the framework will try to find smaller values until it finds the smallest value that fails. And in here, it's telling us that after 9 shrinking steps, it found that if you call the function with mat01 and then mat10, then you have a problem. So, I mean, there's a lot of ways that we could fix this function right now. One of them would be writing the good version of it. Another one would be trying to break this. I think it will be easier for this one. Since it's such a simple function, it's very hard to find a way to trick both random inputs and some fixed inputs. And then when we run this thing here, right, then we save, and then all of our tests should run again, and they will still be good, and so did our property. We'll write one more property for adding. And then, you know what, I actually want to be able, I want to write a version of this function that passes the property test for some cases. So for example, what we saw is that if x equals 0, then we return 2. Or x equals 1. Because the smallest case, we'll try to flip this to okay, no. Then it just gives us a different case. So we will have, essentially, we will have to do or x equals 2 and so on. And that's down this path lies madness. Okay, so we'll just rewrite this function to take the two numbers and just add them together, right? Cool. And we'll write one more property so we get a little bit more flexible with them. We'll say let add is has an identity. And I'm just going to duplicate this so the boilerplate is done. But we don't need a pair of small nats, we just need a single small nat right now. So this will be some number x. And the identity says that if I add 0 to x, I should get the same thing that if I'm adding x to 0. So add has an identity. And then this thing will just run the test for me automatically. Blah, 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 blah. Good. I need to change the name. Addition has 0 as the identity element. And we can write one last more, which is distributed. And for this one, we can request. Actually, I'm going to copy the community one because it's closer. For this one, we can return. We can ask for 3 pairs, right? And then we'll get an A and a B. And, we also get a C. And then we can say that adding A to B added to C to be equals to adding A and B and adding that to C. Formatter, there you go. Addition is distributed. Cool, we can add this to our list of test suites now. And voila. In this many lines of code, we've written about 300 tests, which of course we can bump up to as much as we want. It's a very concise way of thinking of your programs, and it gives you, it's also a very, let's say, mathematical way of reasoning about your programs. But it's a very, very powerful one. And in the future, the first day of next year, right? Hopefully after I go for a run, if we start the year all right, we'll be building something very similar to this for a GraphQL server. And so instead of specifying natural numbers and pairs, we will try to take part of the GraphQL schema and generate a complete whatever. Why would you want anything like that? To do testing against the GraphQL API without actually needing the GraphQL API at all. If you have the schema, then you just feed the schema to this tool, and then this tool will reply to the queries like a normal, like a normal GraphQL server. But for every query, will return random data, which means you can property test your UIs to see if you're actually considering all the possible use cases that the schema describes. Which might not be necessary for some, but for some other applications, it might be very important. Cool, so this runs, it works. Yep. So let's fix now the, I'm gonna do here, add. Let's fix this thing. Let's fix the multiplication. Multiplication has very similar properties, right? It's commutative, it's distributive, and it has an identity. So we can begin with the identity and say mul has an identity and say for some number x that we receive, calling x with 1 should be the same as multiplying 1 by that number. We say multiplication has 0, as 1 as the identity element, and we can just get any small number, and that should be good. So now we can say mul has an identity. Oops, we don't want to add it there. We want to use a different test suite. That's not required. I'm just doing it so that we can have multiple test suites in here. No. So now we run this, the properties will run again, and you can see, if I make this a little wider, oops, sorry, I'm just going to touch this file, that we're running the multiplication test, multiplication has 1, blah, 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 and it works. Let's run it with 1,000. And it keeps working. Okay, interesting. And I wonder why is it working? And the reason is that we always return 0, and that makes sense. Whatever we're returning is going to be the same thing. So we need to do one more check here, and it's that not only multiplying by 1 is equals to multiplying 1 by something, but that should be also equal to itself. So essentially, on the left, and then we can do 1, and then left on the right, this math of mul x by 1 should be equal to x, and then we say on the left and on the right. So if this is true and this is true, then this one and this one are true. Now we can run the property again, and I expect it to fail, and it did. But it did not tell us which one. Yeah, okay. So for the number 1, right, this actually fails. And while we're here, this is not failing because the implementation is good. But we know now that we should probably test it better. On the left, it should be add 0. Oops. On the right, it should be add 0. There you go. Right again, make sure it still works. Good. The only failing thing is multiplication. So now we can go back in there and say, okay, this makes perfect sense, right? We have an x and y, and it's always 0. So how do we fix this? We could say that when it's 1, it should return 1, but then our other test would fail as well. Right? So we need this thing to be 0. So if x equals 0, then we return 0, else we return 1. Now our test passed fine, but our properties are going to blow up. And they do. We found one use case where things are bad, which is 2. So we put 2 here, then this thing will continue to fail, and so on. And this kind of prompts us that, oh, 0. For 0 we also fail. Okay. Prompt us to the right direction. I mean, there's only one possible way of implementing this function correctly. That's exhaustive for this property. And that will be to actually add it, right? I mean, if you know of any other way of doing it, just call me out of my shit and we'll fix it. But this will be it, right? Yeah, the property says, oops, sorry. The property says, I'm going to make the font a little smaller so the test fits better on the screen. The property says that for any number x, multiplying it by 1 should be x. Doesn't matter if you multiply it by 1 on the left or on the right. And you run it 100 times, you can run it 1,000 times, or 100,000 times. It should be the same thing. Yeah, that was really fast. Let's see how fast you can get. So we run this thing, what? 100 million times. This is 100 million randomly generated tests. If it doesn't find any problems there, I mean, of course, it also has to do with what thing we are testing with, right? So if we use a nat here instead of small nat, and we went back to 100, right? Oh, wait, what? Is there no natural number? You can use int. I was hoping to be able to trigger. Oh, right, we're multiplying by 1. This will never trigger that. No integer overflow. Well, we can check now what it's the commutativity one, right? We can do a very similar property for multiplication. Mul is commutative, and then math mul, and then same thing here. And multiplication is commutative, and we just ask for 2 numbers. And I'll run this one with mul is with just 100 small nats first, and then we can try out with let's say 1,000 ints and see what happens. But you can see this is very exploratory, right? This seems to work there. Okay. So now I'm gonna try to stress this function a little bit more and see what happens when you multiply integers. It's possible that we get an integer overflow at some point, and then it's not the same thing. One last more with 100,000, and that was fast enough, and it did not break. Cool. Right, the last one that we want to try out is the distributive property. So we just move that there. I'll just replace add with mul, and then multiplication is distributive. And we can add this thing here. The mul is distributive. And run. And it worked. Good. Okay, so now with these properties, there is no way in hell that we can fake a function that will add two things. But that sounds stupid. Why we want to test the function anyways? You could think of this as a very nice way of generating hundreds of thousands of cases for different methods and functions that you define in your programs. And it not only can build out values that are well known, like small ints or strings and so on. You can also generate your own custom values with this. So if you had, let's say, some user data type user, right? And the user can have, let's say, a name, and that's a string, and then you can have an age, that's an integer, and then you can have a project. This is another type, right? You came up with. Then you can absolutely build generators for these types, and then generate random data that has the types and shapes that you use in your application, so that you don't necessarily have to say, okay, I'm going to build a test user. Let's use a project name and priority int. You don't have to say, oh, this is Joe. Joe is a user, right? He has an age of 29. And the project, he's been working on, I don't know, easy. And the priority is very high, right? This is a very specific test case. And honestly, ideally, we would test our code with a lot of things to try out different assumptions that we or our colleagues have embedded into our programs. What happens if someone out there is just essentially making if Joe.name equals Joe, then give money. Joe. I don't know. I mean, that's perhaps a silly example. But there will be assumptions that you are aware of and assumptions that you're not aware of, and randomly generating hundreds of thousands of inputs for your functions will essentially let you rule out some of them very quickly. Another good thing is that you may find out bugs that you were not aware of, right? What happens if the priority is a negative int, right? What happens then? I don't know. Then that maybe means you don't want to use it. You want to use some type for a natural number. Or you want to use like a int in range, or whatever type you want to use. You will define these types yourself, of course. Well, sometimes. And it's really just a very, very powerful tool to work with. It's a little bit hard at first to grasp how am I going to use this for something that is not just a toy example, like generating, checking the properties of mathematical functions, which are so well studied and so on. And it's also possible that your programs don't actually exhibit any properties, right? It could be the case that your program is just really supposed to pass some tests, and that's it. It could be the case that the only multiplication function that we will ever need is just this one. And that's a value multiplication function for some inputs. I mean, for this is completely valid, and for this is completely valid, right? So no sweat there as well. It's just two different tools that you need to learn to use to be able to really swipe down this, really traverse the space of bugs, of possible bugs that are there. Yes, okay. There's some other libraries that we can use for doing this sort of thing. I picked qcheck because of the name and because I've been looking at some of the things that CQ has been doing in the past. Simon Cron's, he's doing a lot of really cool things. You know, Camel. I think one of the standard libraries is Camel containers. Is essentially something that he came up with. And follow this guy. Where am I? No, come on, browser. There you go. Follow. And I figured it would be good. And it was. It was pretty cool. I mean, we can keep going and just have preconditions that some of these things need to take. For example, assume that the lists that we're getting things from are not empty. And I think over here is where it says, mirrors and trees. Yeah. Here explains a little about how to use how to write generators, right? For recursive types, algebraic types, and tuples. So if you had some sort of tree defined as here, right? And this could just well be our user or a payment or anything that you're working with, then you can essentially use the qcheck gen module to tell it how to generate one object of your tree, and this of course is completely type safe. So then you can use this arbitrary tree to be able to test your code with data that your code understands. Yes, have a look at this. I think this will be all for today. I would very much like to start using qcheck and alcotest for testing some of the projects that we've been using, and I will start doing that first in the HTTP kit library, I believe, and then maybe in Twitchport, which I desperately need not to have to go into my phone to check for the dashboard. That's all for today. I think I'm gonna hack a little bit more after the stream, live, but I don't know. I can't make any promises. I'm gonna put all this code. I'm gonna just add it. Oops, being ignored. We should be ignoring the build folder. Cool. I'm gonna remove the output and then that. Initial commit. If you want to take a look at this, this should be available. Wait, look at my password. I get nervous. This should be available in recent native testing.git. I will make the repo right now. github.com new. In the meantime, native testing. Cool. That was there. Let's add a small README. Recent native testing. Hello. This repo was built during the what is it, 13th live stream of visual coding. I'm gonna throw a link there. To showcase how we can test things with alcotest for unit testing purposes and qcheck for property-based testing. To run this test, you can follow this repo and run. And I think we'll need to do this POM install, and if I'm not mistaken, we'll need some things, recent and alcotest LVT, and then qcheck and qcheck the alcotest, and then make test. But if you do this first step and it works, then everything should be fine. You might need Dune as well. Okay, I guess you can. Or POM or make test will complain and tell you exactly what we need to do. So now let's just do clean all, so we can copy the output of a test run. Cool. Copy it, and then we can put that there. Cool. Now we can add that to the repo, and it will be readme. It'll be a little more obvious what's this repo about. Great. And I'm just gonna do, yeah. Cool. We have everything we need. Great. Cool. Here's the URL in case you need it. Is ostera/recent testing. Have a look at it, play around, and let me know how you're finding out testing in Recent Native. If there's anything that I can clarify, also let me know. I'll try to do it. I'm not an expert in the subject, and I'm definitely not an expert in the tooling. I'm learning as well. So I guess we'll find each other in the Discord channels or in the OCaml or Recent forums. If you like what I'm doing here, don't forget to leave a small follow. I don't see the follow button anywhere here. Oh, Al Montero, as always. Yes, exactly. That's what we ended up doing. I wish I could have had seen your comment before. Yes, I'm signing off already. It's been, what? I don't know, a while. 2 hours almost. Yes. And I've been neglecting some people because of very long streams. But I encourage you to watch it. If you want to do it in 2x if you want, so it will be fast enough. We go through 2 test frameworks, doing 2 different kinds of testing methodologies, and we make sure that some functions are actually running. But as I was saying, if you like any of the things in here, just leave a follow, and don't miss out on the events. There will be some more coming up this week. This is the one that we have right now, and I know that I said 11:30, but I think that we are getting off a little bit earlier today. And I think not tomorrow, but the day after, I'll be talking about profiling in Recent with landmarks. We'll take a look at some of the projects that we built in the past, and we'll try to figure out where are the bottlenecks for them and how to make these things faster. And I expect this one to actually go a little bit deeper into trying to optimize some of them, which will be quite a learning experience for me. So bear with me while I learn that. But hopefully it will be also something that you enjoy watching and that you learn from. And yeah, there will be some more streams coming on. Just make sure to click a reminder. You should probably see a remind me button. Just click there, and then you get a reminder set, and it's great. And I think that is it. Thank you everybody for participating today. And I hope you have a great and happy New Year's. Stay reasonable. I'll see you soon. Bye-bye.